In the given figure, LM is parallel to CB and LN is parallel to CD. Then prove that AM by AB is equal to AN by AD. In the given figure, LM is parallel to the CB and LN is parallel to the CD. Now we need to prove AM by AB is equal to AN by AD. Firstly, let us write that what is given. Given that LM is parallel to the CB and LN is parallel to the CD. Now what we need to prove? We need to prove it as an AM by AB is equal to AN by AD. This we need to prove. To prove this, one must aware about an important theorem of your similar triangles, that is of basic proportionality theorem. Here this is a statement of basic proportionality theorem. Let us see what is a basic proportionality theorem. Okay, if a line is drawn parallel to one side of the triangle intersecting the other two sides at two distinct points, then other two sides are divided in the same ratio. If a line drawn parallel to the one side of a triangle, if you take a triangle ABC, let us take it as a triangle ABC, and here I am drawing a line DE as parallel to the BC. I am drawing a line DE as parallel to the BC. Then this DE divides other two sides. What are the other two sides? As DE is parallel to the BC, then other two sides becomes AB and AC. That means DE divides other two sides in the same ratio. That means the ratio between the AD to BD is equal to AE to EC. Okay, if a line drawn parallel to the one side of a triangle, this line divides other two sides in the same ratio. That means AD by DB is equal to AE by EC. Okay, by using this basic proportionality theorem, we are going to prove that. So let us see how we are going to make use of basic proportionality theorem to solve this answer or else to prove this. Okay, so for this, let us take a upper part of the triangle. That means if you take this line, horizontal line AC as a base, then with respect to of AC, there will be two triangles. One is above to the AC, one is below to the AC. Firstly, I am taking above to the AC. Okay, above to the AC, there is a triangle which is formed, that is of in triangle ABC. They mention that LM is parallel to the BC. LM is parallel to the CB. They mention. That means this is a line which is drawn parallel to the one side of a triangle. So by using basic proportionality theorem, we can say that LM divides other two sides in the same ratio. What are the other two sides here? Means two sides are AB and AC. That means LM divides AB and AC in the same ratio. So as a line LM divides AB into two parts. What are that? AM and MB. The ratio between these is equal to the ratio between the LM to the LC. AL to LC. Okay, let us suppose this is the first equation. Now, if you go to the down part of AC, then we have another triangle, that is of triangle ADC. In triangle ADC, they mention that LN is parallel to the CD. LN is parallel to the CD. LN parallel to the CD. They mention. So again, by basic proportionality theorem, we can write that LN divides the two sides AD and AC into same ratio. That means what are the ratio? What is that ratio? Means AN by ND is equal to AL by LC. This is our second equation. If you observe the equation 1 and equation 2, in this both equations RHS parts are equal. What are the RHS parts? That are Ln by Lc, Al by Lc and Al by Lc. So in both equations RHS are equal. So we can write LHS also equal. If RHS parts are equal, LHS parts also equal. So from equation 1 and equation 2, we can write both LHS parts are equal in this equation. So what are the LHS parts? Am by Mb is equal to An by Nd. Okay. Now here what we need to prove? We need to prove that AB by An is equal to AD by AB by AM is equal to AD by AN. This we need to prove. Okay. To prove this, if you observe this equation, we got a third equation. In this third equation, what do we have with respect to what we require to prove? We have AM and AN. We have, and what we don't have? MB and ND. That means from the equation, if you are able to eliminate these denominators, so we may get a required one. So to that, what I am going to do is I am going to apply invertendo. Sir, what is invertendo? Means if A is to B is equal to C is to D. Here is to ratio I wrote in terms of fractions. So these two ratios are equal, means these are in proportion. A, B, C, D are said to be in a proportion. In this proportion, for this proportion, invertendo means B by A is equal to B by C. That means apply reciprocals to the both sides of the equation. So here also I am going to apply reciprocal for the LHS and RHS at once, so that we can get it as an MB by AM is equal to ND by AN. Now I am going to add 1 on both sides. Add 1 on both sides. So and adding 1 on both sides, we can write it as an MB by AM plus 1 is equal to ND by AN plus 1. And this 1 I am going to write it in terms of another terms. So in what manner I can write? Means to add them, I am going to make it as a like fractions. So to make them into like fractions, 1 I am writing it as an AM by AM. In the same manner, this side 1 I am writing as an AN by AN. So on writing, so we can add very easily on the both sides. We can add these fractions very easily. Why? Because they turns into the like fractions. So as they turns into like fractions, so MB by AM here, mistake. Okay. Now as both terms are the LHS are having same denominator AM, so I am writing as common denominator AM. Then I am adding MB plus AM is equal to, and RHS part also, these are like fractions, so I am writing common denominator AN and adding numerator AD plus AN. Now if you observe the diagram, first part if you see, LHS part if you see, numerator part of the LHS, MB plus AM. MB plus AM means what we got? MB plus AM is what we got? Total AB. That means MB plus AM is equal to AB. Then AM I am writing as easily. In the same manner, ND plus nd plus an. I can write it as an nd plus an. I can write it as an ad by an. Now, if you apply invert endo, so that we get what we require. So, on applying invert endo, I can write it as an am by ab is equal to an by ad. This is what we require to prove. Okay, I hope you all are understand this problem how to solve. Okay, so thank you friends for watching this video.